Hey, welcome back. This is part 2 of my previous video, linked in the description below. In part 1, we discussed about representing an application config using a simple case class, and then we described the retrieval of this config using zio-config's config descriptor language, which is then passed to a read function that then returned a nicely represented error message or an application config. In this video, we complicate the use case a little bit and hence the config itself, and we proceed from there. We will finally talk about deriving this description automatically while keeping this idea of, hey, let's try our best to push the behavior of an application into the landscape of types and hence achieve reliability through logical consistency. Okay, up until now we had these 4 config parameters that needs to be passed into the application. One is host, the next is port, username and password. This is related to a database config. Although we say it is an application config, all of these parameters are something that is related to a database config, and our application is not going to work without these configs. Now we're going to add one more configuration parameter into this application config. Let's say it's a region. Now for those who are familiar with cloud like AWS, you know what a region is. Now where exactly your application is going to run is the most simplest explanation to what a region is. So let's add that. Okay, and a region is going to be a string. Well, a region is a string which can be optional. Okay, let's say it's an optional parameter. Now why did we say it's an optional parameter? That's because even if a user is not passing a region into our application, it's okay for us. All right. Now, how do we represent that behavior in the application config? We have seen a little bit of this idea in part 1, and most of you might be knowing the answer is option, because an option can represent both the presence and absence of a value. So a region may or may not present, and it's okay even if the user is not passing it in. And we are representing that using types. And obviously our description failed. Our description is now complaining, well, I cannot form an application config because you try to retrieve only host, port, username and password. Now we need to retrieve region as well. And a region is a string. But then it's still complaining that, well, it's expecting an option of string, but you're passing a string. Now, in zio-config, you have this combinator called optional. And that will make a string of region an optional parameter. And then we are passing that to application config. Really simple, right? Very simple. So that's it. So that is all about optional parameters in zio-config. Now we are going to complicate this use case a little bit more, where we're going to say that, okay, let this application be an ETL framework that's going to read some source, process some data, and do something with it. Our do something is basically a println. Anyway, for now, the database is our source. Now tomorrow business is coming and saying, look, database is one of the sources. A user can pass either a database or they can pass an S3 path, which means a different type of source itself, into the config. Our application should be able to accept either a database or an S3 path. S3 is a service hosted by AWS, and it's attributed by mainly an S3 bucket and a prefix. Okay, so if the source is S3, that means you need to pass an S3 bucket and a prefix. If the source is not S3, you have to then pass a database, which then should have host, port, username, and password. Now, how do we describe this in our types? And it's quite simple, but we need to do a little bit of cleanup here. First thing, we're pushing all of our code base into one file, and that's not going to be maintainable. So let's push this application config into a config class. So that's our application config. Now we cannot add a S3 bucket and a prefix into the same application config, because this now doesn't represent the logic that we were talking about. This means user has to pass all of it, and that's not what we're talking about. We need to talk about either here, some kind of OR logic. And we have already seen this OR logic. We have seen that as either in Scala. We said, well, this is an example, right? It can be a read error or it can be an application config. And we make use of the same either in this case. Although either is a suboptimal way of representing OR logic in Scala. There is better way of representing OR logic or core products. But we are not getting into that part yet. For now, we will use either, and theoretically it's correct. Okay? So, but our config is a little bit flattened in a way, and let's modularize it a little bit. Let's clean it up a little bit. So this is a personal preference. I tend to add all of the details about a data structure in its companion object. So I have a companion object called application config. Within this application config, I can have a database config that has host, port, username, and password. I can also have a S3 bucket where you need to pass in a bucket name and a prefix. So and is represented using case classes. This is a product. And then now we need to represent one more logic, either a database or an S3 bucket. And that's quite simple. Our source is either a database or an S3 bucket. And we don't need prefix. And regardless of what the source is, you need to pass a region. Now this looks way, way better. But then we lost. Now, where do we represent the description of the config? Again, I tend to put that into the companion object of each data. Which in this case, we have to represent the config. Now, config descriptor is a config descriptor of application config. Import zio-config config descriptor _. All right. Now, before you go ahead and start implementing the logic to derive config descriptor for application config, let's solve this problem one by one. Okay. We need to have a description for database config. Okay. So let's put that into the database companion object. Again, this is a personal preference, but that's an idiomatic way of putting things in Scala, organizing your logic in Scala. All right. Val config is, let's call it as config instead of config descriptor. Okay. And this is not going to have any conflicts because it's namespace through the companion object. So this is application config.config and this is database.config. Okay, I think we have already implemented the config descriptor for database. Not fully, this is application config, but all of this is basically database except region. So let's copy that. And then let's put database.apply, database.unapply. Okay, it's quite simple. Now, to repeat one thing, you can do all of this in one go as part of this logic, but this is just to get better maintainability. And we do the same for S3 bucket. For S3 bucket, its config is a string of bucket name and a string of prefix. Let's say S3 prefix. Prefix is a very common name. And then we pass that to S3 bucket.apply, S3 bucket.unapply. All right, this, we already got a config descriptor of database in a similar fashion, right? Config descriptor of S3 bucket. And here we say database.config or else either S3 bucket.config. Now, along with this, that's not only what you require. You need to have a region, which is a string of a region, and that's an optional field. I've got some train noise in the background. Sorry about that. Database.config or else either S3 bucket.config, and we pass it to application config.apply, application config.unapply. All right, this says database config or else either S3 bucket.config, and that's going to return a config descriptor of either of database or S3 bucket, just for some understanding purpose. Okay, database or maybe source is database config or else either S3 bucket.config, and that is a config descriptor of either a database or S3 bucket. All right, and this is going to give source. We haven't talked about the actual configuration source. This source is the source of our ETL framework, right? The database data source. Let's say database source. Okay. So our database source can be either a database or an S3 bucket. That's it. Let's rename this config to application config itself. I think it's complaining about that to satisfy IntelliJ. Done. We go back to main. We don't have these descriptions anymore. We say application config.config from system environment. Now, instead of database host, username, port, we pass bucket name and S3 prefix instead of password, port. All of these are database, and we are not passing region because region is optional. So bucket name can be some bucket and some prefix. Let's run this. It says a write of S3 bucket, some prefix, and region is none. So remember that our application config is super expressive. We can do anything with it without assuming anything about the behavior of the application, because those assumptions are channeled into the type system, into the landscape of types. So for example, my application config dot source or data source, if it's matching a left of a database, or a write of a S3 bucket. Now I need to handle S3 bucket. Now this is this is just for demonstration, right? At compile time, you are forced to handle both these scenarios. What are you going to do if the source is a database, and what are you going to do if the source was a bucket? You can also use fold. Now that was just giving you an idea how we can use either. And to repeat one more thing, what happens if I have one more source and your either becomes super complicated? Well, the answer is, as I said, either is a suboptimal way of representing this behavior of application. So in the next part of this video, we will discuss about ADTs, algebraic data types, and how zio-config can solve all of that problem. That's it. One thing, the intention of this video is not to sell the functionalities or the features of zio-config, but to give you an idea of representing the behavior of application into the type system, and thereby how much we can attain the readability and maintainability and reliability. Sometimes it can look verbose, but it also brings so much of logical consistency into your application. Before we finish this video, we can talk about automatic derivation. Okay, this is just giving you an idea of how that would look like, and we will get into the details only in the next video. So automatic derivation means obviously you don't need all of that bit, right? You only need one simple statement, which is import zio-config.magnolia. I think it's not imported yet. Again, in the build.spt, I have a dependency called zio-config magnolia. Without this dependency, you won't be able to derive anything automatically. And we come back. But in the application config, done. That's it. You don't need database. You don't need S3 bucket. But we also deleted the name of our keys too. So how is this descriptor going to identify what the names should be? From now on, the names will have to be the field names. So if you're passing database, it has to be matching exactly the name that you have passed in the case class. You can customize it. Again, part of another video. I'm not going to complicate it further, but we will pass the exact names in our source and we'll be good to go. Back in the main, we can't use these names. We haven't said that anywhere because we are using automatic derivation. Now, this automatic derivation is compile time safe. That means if it is not able to resolve any of these types, it's going to complain about it. And it is also going to make a good assumption. That is, within the database source, you can have a bucket name or a prefix, bucket name and a prefix, or within the database source, you can have host, port, username, and password. So the way it's going to derive it is, you have to nest your config within the database source. But to give you an idea, what that means is it should be within database source. And in a flattened structure, the only way to represent nestedness is putting some delimiter. And then we pass the exact, actually it shouldn't be a database source, it should be a data source, isn't it? Okay. So within a data source, it can be an S3 bucket, which is bucket name, and prefix, right? Some prefix. Good. But then in the map, you have to make sure that you specify the delimiter as underscore to represent nestedness, and that is key delimiter is sum of underscore. All right, let's run this. We got application config, right, of some bucket, some prefix. Now if you give bucket name, instead of bucket name, host port, username and password, username, password, it's going to give you a left of database. So that's it for this video. Catch you for the next one.